has two independent means testing. It's at the back of page 1, I guess it's page 2, technically speaking. Do children diagnosed with ADHD have smaller brain volumes than those without? So that's the research question. And Sherry's going, who cares? I don't know. I read this result, and I'm like, that's kind of interesting. Well, I don't know if it's nice or not nice. I mean, I'm viewing it completely objectively. I remember reading a story about Einstein's brain being larger than most brains. So I was like, maybe he's the opposite of ADHD. NDGE, I don't know. So here's the American Mental Association study, 2002, a little bit old, but not horribly so. They recorded this data. Check it out. 152 ADHD kids, 139 non-ADHD kids. What's the first thing you question right now? Well, maybe. Actually, I printed probably, believe it or not, JC, and this is something, again, your exam gets into, is when you're testing averages, you don't need, in general, as large a sample when you're testing proportions. Believe it or not, it's hard to maybe process that right away. But you'll see why on your exam. Thank you, sister. I was thinking even more general than that.
What's millimeter?
Say that again.
What is the definition?
What is the definition of ADHD, and can we rely on all 152 of those kids to be ones and all the 139s to be zeros? I mean 1 and 0 binary. Yes, you have it. No, you don't. There are gradations of that, just like there are gradations of anything else. So that's one of the first things I question is, even if we get results, if the data itself was compartmentalized wrong, just keep that in the back of your mind whenever you see something like this. Just keep that in the back. We're focused on mechanics, but I like sliding that in there too. Just keep that in the back of your mind. Any results we find might be nullified by that. Potentially. Okay, well look. It looks like the ADHD kids have smaller brains. Look. About 1 liter for the ADHD kids. They measure the brain volume in milliliters for whatever reason. 1,059.4 milliliters. To about 1,100 for the ADHD kids. That's like a half a liter-ish, something in there, right? Half a liter, 0.4 of a liter, something like that. I don't know what to track. Look at the difference. Milliliters.
Is it like half a deciliter, maybe?
1.0 versus 1.1. That's a tenth, right? Oh, a tenth. Excuse me, not a half. Tenth. I said the wrong word. So a tenth of a liter different-ish, somewhere in there. All right? But the question, of course, is that meaningful? Yeah, it's less, but is it meaningful? I don't know. I also included the standard deviation that they gave me for each of the samples. It's about the same. And this goes back to that question Lauren had about the pooled versus non-pooled in the tests. And basically, you don't worry about pooling anything anymore because of technology. But these look to be essentially the same standard deviation. So this will be one of those things where it would be okay to pool if you needed to for whatever reason, although you won't have to. So let's test it.
Is everything else the same, like the same age?
Yes. Yes. The idea is you control for every variable, except for that ADD or not. So, let's do it. ADHD brain volume. That's a B, ADHD. Attention deficit hyperactivity. Badass. Let's grab a template. I got more templates up here if you need them. We are testing. But what variable? The mu. Exactly. And technically speaking, we're testing 2 of them, aren't we? We're testing good, and we're testing 2 brain volumes, aren't we, on average? mu1 and mu2. Your guys' call as to which one is which. I don't care which one you call what. Which mu1 going to be? Average brain volume of? Love it, Michael. Here's the ADHD kids. Average brain volume. Which makes mu2 the non-ADHD kids' average brain volume. Doesn't matter to me how you assign the variables at all. Doesn't matter to me one bit what you do. Don't keep your signs straight. You get a lot of flexibility with these tests. A lot of flexibility with these tests as far as how you set them up. As long as you keep straight which one is going to be represented in the claim. So speaking of the claims, and this is back to Jamie's question, I love what you're saying. You're saying you're having a hard time identifying which one of the hypotheses goes where. Keep this in mind. Whatever your claim is goes in the second one, your alternative. So what's the claim implied in the question that leads this data set?
With ADHD have smaller brains.
Boom! That's going to be H1 or HA, whatever you call it. People with kids with ADHD have smaller brain volumes than those without. So I'm going to slap the variables in here, mu1 and mu2. What's the inequality going to say if we're testing that question? JC, go ahead. I hear a vote for less than. I see lots of. Sherry's saying yes, we're going with that. Okay, good. Everybody's like, so she said, y'all just looked around at me. What do you think? Is that what's being claimed? The average brain volume of ADHD kids is smaller or less than the average brain volume of the non-ADHD kids. Yeah, absolutely, I totally agree with that. I want you guys to feel confident about it though. And I know part of it is the fact that we're still using these damn inequality symbols. They have alligator mouth from like pre-algebra days, and they have the scars. Because that's when math stops being fun. I know that. Okay, the null is going to be whatever's opposite. And you guys, how do you guys like to write the null? Just equals? Cool. Absolutely. You got many, many choices. That's totally fine. That's pretty industry standard. That means there's no difference at all between the brain volumes. Cool. So, I'm going to draw a little curve, if it's okay with you guys. So here's 0. That would be that mu1 is equal to mu2, yeah. That mu1 is equal to mu2, that orange underneath. As we start going this way, we start getting negative, which would imply what about the mu's? If we start heading this way, if it's getting negative.
They're actually bigger
Which one?
in one.
Good.
U1.
I mean, if we start heading left or right, now I'm going to go off the sign we have here.
Right.
This is a left-tailed test, yes? If this is a left-tailed test, that means this guy's smaller than this guy. That means we want to head this way. So somewhere over on that left side, we're going to slap a region beyond which the 5% area lies. If we end up down there, if we end up down here, then we're going to take a second look at our data and say, okay, it looks like the ADHD kids have smaller brains. Does that make sense? So that means this side over here is going to be the mu1 is less than mu2 side, if we start heading this way. Now we might get surprising results. This is actually what your first exam question does. If we start heading this way, that means the ADHD kids actually have bigger brains than the non-ADHD kids.
I have a really strange question.
Go ahead.
So a left-tailed test, the alligator's tail points at a left tail.
I stay away from the alligator.
No, I want the alligator.
No, well you gotta get from somebody else other than the alligators. The alligator confuses, whenever I try to explain the alligator, it confuses students. So if that makes sense, please.
Well, I don't know if it's true or not.
Here's an easier way to think about it. Here's an easier way. That's fine if you like it, I just can't explain it. Look where it's pointing. Look where it's pointing. Think of it as an arrow. It's pointing towards the tail where the region's going to be.
Okay, that's what I'm.
That's a much easier way than creating some fictitious third object. Mouth. Look at it as an arrow. It's pointing towards the tail. It's pointing towards where your test statistic needs to be. Now, mathematically, why that makes sense. If you rewrote this, now I'm not saying you have to do this, but if you rewrote this as something with 0 on one side, you brought this over to this side, you'd have mu1 minus mu2 is less than 0. That means this is negative, less than 0, which is why it would be on this side of the curve. Mathematically, does that make sense?
Yeah.
And if it were greater than 0, it would be on that side of the curve because positive numbers are above 0. So that's the way I like to think about it because it doesn't involve large reptiles. But also because I've never had any luck explaining that alligator to anyone. I'm not saying you can't. I'm just saying I can't do it. I can't do it. I'm not saying it's not. I'm saying I can't explain it. Cool? So that's why you got 0, you got negative, and you got positive in that respect. So let's see where our data falls. Actually, let's talk about the errors first. What would type 1 be? What would type 1 be?
Saying those who have ADHD, their brains are smaller.
Yes, indeed, but
They're not.
how about a type 2? Did you ever hear what JC said? saying the ADHD kids actually have smaller brains, but they don't have smaller brains. They don't. Now, of course, this is the type 1 error with chance of 5%. We're not saying that's true. We're saying that's a possible consequence. There are 4 possible consequences of any hypothesis test. The 2 errors and the 2 correctors. So, you know that word right now. So that's type 1. What would type 2 error be?
That say they don't have smaller brains than they do.
Good. That's missing the fact their brains are smaller. So we run the test. We get a large p-value, and we say, okay, well, it doesn't look like ADHD kids do have smaller brains after all. But guess what? They do, and you missed it. They do, and you missed it. All right, your opinion. Oh, Renee, question, comment.
Wait a second. Type 1 error is...
False. Oh, go ahead, I'm sorry. Finish your statement.
mu1 is less than mu2?
Mhm.
Or I have it opposite?
You believe that mu1 is less than mu2, but
Okay.
it's not.
Okay.
Yeah, type 1 error is always going to agree. It's when you believe this when you should have believed this. Type 2 is you believe this when you should have believed this. Does that make sense?
For type 2, can we do it the way you did it with the that and the that instead?
With
the
the-
less than with the line going?
Oh, sure,
I
absolutely.
like that better.
You guys voted for that, though. That's fine. Whatever you want. Which one's worse? Type 2, missing what's out there?
Yeah, because it could be relative to some other issue.
Sure, it could be tied to something else. And if you don't actually catch the issue, you might not look for that issue tied to something else later. I like that, JC. That's good. So that was a vote for type 2. There might be a condition that might be tied off to something else. Very often, doctors like to use that when they're diagnosing. Oh, you have a family history of blah. Oh, you might be at risk for blah. Now, sometimes that's also erroneous, but if it's not done erroneously, that's actually important. Please,
I say type 1.
go, tell me why.
It might create more inadequacy or whatever that word.
Imbalance. I love what you're
Those
saying.
kids that are already battling with this struggle and they feel less than.
Not that I have any personal experience with ADHD.
I-
I'm completely facetious. I was diagnosed when I was 5. Totally in agreement with that. That disorder in particular has got so much, it's weird, but it's got so much stigma attached to it. I never felt the stigma as a youngster. I just was the freaky Sean dude. But like, there is a stigma, like, oh my God, why can't you just blah? Now you add this to it, oh, you're a tiny pinhead. I mean, who knows what repercussions that could have? Good!
A lot of lower expectations.
Quite possible. Exactly. Self-fulfilling principles. Good, good. I love this. Type 1, type 2. There's no one right answer. It kind of depends on what your viewpoint is. Good.
I've had ADHD.
Hang on a second. Go ahead, JC.
So, you know how when we test to see if there's a difference?
Yes.
2.5 and 2.5
Yes.
on this side. So when I think, I don't know this exactly, but when I think of doing this test to see if they're smaller, we're just testing the one side. So in my mind, I think, have they already tested both to see if there is a difference? Because if they have done that, then this makes sense to me. But if they're just jumping straight to this, that's confusing to me why they would do that.
And I love that you just said that. That was a fantastic question. She's like, wait a minute, time out. How would they even get? Well, first of all, where would the research question come from? And I think it makes great sense to realize that it would start with a two-tailed test. Meaning you would say, I wonder what differences ADHD kids have with non-ADHD kids. A lot of times it's called data mining. You have a bunch of data, whether it's BMIs or body surface areas or brain volumes or heart rates or whatever. I'm not saying BMI is worth anything. And you start data mining it. You start seeing, okay, are there any differences here or here or here or here? And when I say differences, I'm using it just like you did, JC, two-tailed, seeing, not going in biased with a direction. So you go in looking for a difference first. If you find a difference, there's actually no need to do a one-tailed test. If you have significance on a two-tailed test, you automatically have significance on a one-tailed. Does everybody see why that would be the case?
Because it would be 2.5%.
Right, check this out. I'm gonna redraw this momentarily and then come back. So I'm gonna add color, rather than redraw, I'm gonna add purple. If we were testing this two-tailed, we would have a region out here, and that would be 2.5. This is a fantastic question, JC. And a region out here, that would be 2.5.
So is it because the likelihood of it falling in because it's even smaller?
Yes, that's exact. I used a phrase last week called a higher proof of burden. You might remember that. You might remember. You probably don't. It's been a long time. Higher burden of proof. Saying higher burden of proof. If you can get two-tailed significance, you are guaranteed one-tailed significance because of that. If you've got two-tailed significance, you're landing either here or here, yeah? Well, once you landed either here, suppose you landed down here. Well, then you automatically have one-tailed significance, more area. That's why a lot of statisticians go straight to two-tailed tests. They don't even bother picking a side, because if you can prove it with two, you've guaranteed got a direction.
So is it, I'm maybe thinking about it the opposite way, like thinking it'd be better to do the two-tail first and then go to it, but that.
Many statisticians agree with you, sister. Many statisticians agree with you because...
But why? Why would you do that?
Because a higher burden of proof. If there's significance, it'll be more significant with two than one.
I think I worded that differently. Why would you do the two-tail and then switch it to the one?
Oh, I'm not saying you would. What a lot of crappy statisticians will do, though, is start with one and switch it to two.
Oh, is that same thing?
Because the thing, if you have two-tailed significance, you automatically have one-tailed significance. The converse is not true. If you have one-tailed significance, you don't necessarily have two. I mean, think about it. If you have one-tailed significance, your p-value might be 4.8%. Well, that's not over here. But it is significant in the 5% rule for one-tailed testing. Is that fair? This is where the great question came up from before, and I think Kate asked it, about, wait a minute, what if it's close to 5%? Close to 5%. I say, if it's close to 5%, replicate. 5% is somewhat arbitrary, and we've already decided that if you don't want to make a certain kind of error, you should change that anyway. If you want to avoid a type 1 error, make that 5% 0.1%. So it's not a fixed value except for in this class because I'm focusing on other stuff besides that. Research methods classes will get into this greatly. Go ahead, Lauren.
So, could you slant a study because you...
Probably.
Well, okay. But you do a two-tailed test, it doesn't have significance, but it would in a one-tailed test, so then...
That's exactly what I would call bad statistics, yeah. You see, so do a two-tailed test, get a p-value of 8%, and then go, hot damn! If I do a one-tailed test, it'll be 4%.
Right.
Yeah, that's crap. I mean, yes, you could do that for sure. Let's see if they did that here.
Yeah, how often?
Let's see. Let's see. We're going to tell within 2 seconds if they did that here. Now, how often would it happen? God, I hope never. I hope never.
So easily, though, because there's money behind it.
Oh! Now, you're getting into something besides mechanics here, Lauren. I'm not saying I doubt you. I'm not saying it doesn't happen. I'm saying, my God, as a purist, I hope it doesn't happen. Michael, yeah, I'm not doubting you. I'm not doubting it does happen, but I'm saying I hope it doesn't.
Well, for this specific example, this ADHD versus
Sure.
non-ADHD one, wouldn't we just do a one-tailed test because we already know from the stats we have that it's smaller?
And that's the question. At what point is the hypothesis formed? Is it formed before the data is collected? That's where the two-tailed test makes sense. But if you have the data and you look at it, you're like, oh, it looks like ADHD kids are smaller. Now we measure if it's significantly smaller. Then a one-tailed test makes perfect sense. That's what you were getting at, JC. So it's kind of at the temporal point at which the hypothesis is formed. If it's formed before you even collect data, you're sitting in an office, drinking coffee with your partners, and you're figuring out what to test, two-tailed tests make the most sense because you have no idea. But if you have the data in front of you, we're looking at it and going, oh, look, it looks like they're smaller. Then it makes perfect sense to run on one-tailed. But the burden of proof still holds. Thank you. Good questions. Good question. Let's get into it. Let's see. I want to put Lauren's mind at ease. If this was actually done, let's put this on top of that and see if this looks decent. Let's see if we got a small p-value, but not so small as if the 12. Let's just get into that. All right, here we go. Stat tests. We're going to run 2 sample t-tests because we're testing averages. Yep. We actually have stats in this one, and you will very often have stats given to you in articles. Very, very rarely will you actually see the raw data given to you for an average study. Very often they give it to you just like this. You get your sample size, your average, and your standard deviation. That kind of sucks. And it kind of sucks because you can't do things like test the normality. Is it bell-shaped? Are there outliers? You can't do any of that without having the data in front of you. It's kind of annoying, but you know, whatever. So let's fill it in. Let's see, X bar 1 is the ADHD kids' brain volume with their standard deviation. There were 152 of them. 1104 and a half. And 139 of them. We are testing that one actually, right? Less than? Guy right there. He's blinking on that. Yeah, testing that one. Good. Don't worry about pulling. No need to pull. And finally, let's draw it and see what it looks like. Hell, actually, if we had seen anything, we would have already seen it. I mean, I was waiting for it to show up on the right-hand side, but if we were going to see any area, since it's a left-tailed test, it would have been down there. And it is down there. But where is it down there? It's pretty far down there. So here, if we landed here or close to here, we'd be thinking, okay, these kids have the same brain volumes. If we landed over on this side, we're like, holy crap, ADHD kids have huge brains compared to non-ADHD kids. But look where we landed. Negative 3.4, what? Standard deviations away. Negative 1, negative 2, negative 3. We're down here. Laura, go.
Will you help me? I'm getting an error.
What's the error?
Invalid dim.
Turn your plots off.
Okay.
I guarantee that's what the problem is. I guarantee you got plots turned on that are trying to plot blank data. Which is always, if you ever get an invalid dim error, just turn your plot. Well, 2 weeks left. Almost done. Almost done. Thought about it. That happens so frequently with the TIs. I wish they were smart enough to turn themselves off. So what do you think? What do we believe? Are the ADHD kids' brains bigger? No, because if they were, they'd land over here. Are they the same as these guys? No, because if they were, they'd land somewhere in here. It sure looks like they're less. So here's what's this numbers, 7, 8, 9, or 8, 9, and 10?
6, 7.
Oh, 6, 7. Okay, so 6 was T. We kind of skipped over that, I apologize. T distribution. Test statistic, we got it, negative 3.4. P-value, that tiny little thing, 0.0004. You can call it 0 if you want to. I wouldn't, I'd put the value down, but you can go wherever you want. It's less than 5%, right? That's the big deal. It's less than our cutoff of 5%. Much less, actually. I haven't forgotten JC's question yet, or Michael's question, I forget who it was now. So what do we think? What's our conclusion?
ADHD brain volume is significantly smaller.
Sure does appear. It appears that ADHD brain volume is significantly smaller. Could we be wrong?
Yep.
Of course. Which way?
Type 1.
Type 1. Type 1. Type 1. We said it was when it actually wasn't. Yeah. There you go. There you go. Could, I want to go back to JC or Laura now. I can't remember who posited the question first. It's freaking awesome. What if somebody runs a two-tailed test and gets kind of a small p-value but not quite 5% and then says, let's just run a one-tailed test and call. Could that happen here?
No, because
Hell.
if you double it, it's 0.
Exactly. Hell no. This thing is so small that even if you double it to make it a two-tailed test, this thing it's still way less than 5.
Wait a second. This is a one-tailed test.
This is a one-tailed test, but my question was, could this be the case where somebody ran the test as 2, didn't get the significance, and then said just lop off one of the tails, call it 1, and call it good? No, that couldn't have happened mathematically. It's so damn small that it couldn't have happened. So now, what are a couple questions from a research methods point of view you're going to ask next? Number 1, does it matter? Give me more than does it matter.
Well, does the volume matter with the activity of the brain?
Good. Does the volume actually mean anything? Awesome question. Dana, go ahead.
It's just stated children, are they all the same age?
That was controlled for, yes. But that's worth looking at before you even run the test. Good. Lauren?
Does brain volume correlate to ADHD?
Ah!
Those with smaller brains, do they have ADHD or just those with ADHD?
So did we find a foregone conclusion, essentially? If that's one of the factors of ADHD, why would you spend government money to find this study that was a foregone conclusion? I like that, Tim.
Is one part of the brain smaller, or is it overall?
Oh,
Is it
good.
a particular part that has attention?
Topography of the brain. I like that very much.
Or is it-
That's clever. Is it one like the cerebellum or whatever the hell it's called, the
Whatever
hippocampus?
controls attention.
Good, good. Oh, good.
And is there a cause?
Is the brain
Plastic.
plastic?
Like, can it grow?
Oh, gotcha. Can it grow? Can it be changed even? Oh, that's another research question. Like a brain, like a bird's brain, literally. If they damage a part of a bird's brain, it'll regrow that part of the brain. Oh, that's
Or
interesting.
still growing. Like 6
But if there's a deficit in the brain volume, can it correct itself?
So,
You guys are awesome. I was just thinking, how much smaller is it?
Oh.
That's I was thinking, such a simple mathematical. How much smaller? Obviously, it's less than 0. How much less than 0? That's how I was thinking of. But your guys' answers are way better. You guys are like, is it meaningful? That's a much better question. Is it a meaningful difference, or do we just find something that's worth putting into a research journal and forgetting about?
Yeah, what is it, like a half a milliliter?
Well, that was our sample.
Yeah.
What we just proved was, even when you put a margin of error on our sample results, it still holds up. So you could, I mean, theoretically, check this out. You can run a confidence interval. You can run a confidence interval on your samples. If you look at tests, you can find something called 2SAMP-T-int, right down there. 2SAMP-T-int. It's just like T-interval from before, but it deals with both samples. So if you run that bad boy, here's your data, it calls it right in because you already had the data in from your last test. And if you look down, it looks exactly the same as everything else, except it asks you for a confidence level of, say, 95%. Don't worry about pulling it, calculate it, let it think a little bit. Let's slide it over here. There you go. There's your confidence interval. It's at least about 19 milliliters smaller. In milliliters, right? The units in this is milliliters. So it's at least 19 milliliters smaller, maybe as much as 72 milliliters smaller. So the question then is 19 milliliters meaningful? This is the first question I go to. If I got a small p-value, let me make a confidence interval and see what the difference is. I don't know if that's meaningful or not. I'm not a brain person as far as this goes, as far as that measure this brain person. What would you call that? Child psychologist? Neurologist, thank you. Child, yeah, whatever. I'm not a brain person. Hey! They can't see that on the sideboard there.
That's a gigantic interval. Yeah.
It is, but remember the standard error of the 111, the standard deviation, I guess, of the 111 kind of forces it out. We've got a very small sample, right? Or a very large sample, which should drive the standard error down, but when you attach that, your standard deviation was 1/10 of your average, if you think of it that way, right? 100 versus 1,000. That's fairly wide as far as standard deviation goes, so you got quite a bit of variability. That's why I want to look at outliers, but I can't without the raw data, so that's one of the problems with this kind of test. And Michael!
So how did we get such significance when both of the averages are within 1s of each other?
The answer is, Michael, I love, can you ask that question again?
How did we get such significance when both averages are within one standard deviation?
May I? This is such a freaking awesome question. I want to go back to that sheet, and it's a sheet that you guys have for a quiz this week if you choose to do it, the error quiz. I want to refer back to it because I think the Excel sheet that I made will actually answer this question very well. Better than what I can draw on the board. But the answer is, you can make anything significant if you want to. And here's how. This is the problem with, I think, piss poor statistics. Okay? Thank you, Brandon. And thank you for this question, Michael. It's so good. Where's it? I think it's 14. Oh, there it is. Oh, you can't see that.
Is it just because it's significant that they're different?
Well, watch this. I can prove to you why. Mathematically, this is mathematical proof, not practical proof. But that's all we're looking at is mathematical differences, right? All right. Here we go. Here are your null curve and your research curve. Now, you know where this one is, because this is where you start. You compare everything to this. You don't know where this one is. It's out there somewhere, generally off. Well, if it's significantly different, it's generally away, quote unquote away. And you can move that bad boy to the right, to the left. Now clearly, if you move it further and further right, there's obviously a difference there. Now the question is it a measurable difference? But your question is not that. Your question was, it sure looks like these curves are like this. Well, like you said, within 1s. So if I'm calling this S down here, which it technically isn't, technically it's a standard error, but let's just call it S for the time being. Okay, fair enough? If you do that, it's like, how can these be significantly different from each other? Simple. That's how they can be significantly different from each other. You see how close? Those have not moved with respect to each other. They're still the same unit distance apart, but the standard error has shrunk down and become so small that the statistically significance. Now, and this is the problem, a lot of studies, check this out when you guys go out to your jobs and your careers. Look at these studies where all they do is collect other studies and put them into one big study. and they claim a large sample size. Well, this one over here was done with 56, and this one over here was done with 120, and this one over here was done with 250. You put them all together, all of a sudden you've got a sample size of 3,000. You've made an assumption that every single one of those studies went exactly the same. Number one, they probably worked. I can almost guarantee at least one was done differently, so you shouldn't be combining them together anyway. You should view them as that many different studies as opposed to now one large study. But this is how you can mathematically make it happen though, Michael. You see what's going on? And that's the problem. I think that is a problem, I think, of a misinterpretation of statistics. Just because something's statistically significant doesn't mean it's practically significant. It just means it's numerically significant. And that's all 244 is about, is measuring that numerical significance. That's all it's about. Fair? Great question. And it drives home the point, again, I started mentioning this 5 weeks ago, but it drives home that point with that as well. If you make your standard error, or your sample size go up high enough, your standard error will shrink down low enough, and all of a sudden, a 0.001 difference can be significant. If your sample is 40,000.
But then, so it's different because the numbers on the bottom are standard error, not S.
Well, these don't move because Excel's a pain in my butt. But yes, standard error is making the significance. 95% is still within two standard errors. But because the standard error is a function of the sample size, it has to go down as the sample size goes up. Fair?
Well, because the way that graph looks, it looks like, I mean, obviously, the one on the right is past 95% completely of...
Are you looking at the blue part that's shaded?
I'm looking at, just in general, the curves, then the standard error is not 117.
Oh, yeah, don't look at these 0 and 1. That is, as soon as I start messing with the sample size, that Excel doesn't follow, which is, it doesn't follow the curve. Let that go. Let that go. But just the curves themselves no longer overlap, which means they're significantly different, but only numerically significant. Only necessarily numerically significantly different. Very good question. Thank you. Let's take 5. That was a great, like heart questions, like right to the heart of the matter questions. Thank you guys.